In lesson 8.4, we're going to work on scientific notation. Now, scientific notation is just a way to write numbers that are either extremely small or extremely large. Scientific, obviously, because it's a lot of this stuff is used in science. You probably have already learned this in science because when you're dealing with data and results and you're doing experiments and things like that, a lot of times you have extremely small or extremely large numbers. So, what we're going to do is the first thing that we're going to learn how to do is take a number that is already written in scientific notation and we're going to expand it and write it in what we call decimal form. So what I look at here is I've got two parts to a scientific notation problem. I've got the number that we are going to use and then times 10 to the whatever power they gave you. Now, the power that they give you, every single scientific notation problem is times 10 to whatever power. It'll never be times 9 or times 8, okay? It'll always be times 10 to a certain power. If the power is positive, we move the decimal in this part of the problem to the right because we're making the number larger. If our exponent is negative, we move the decimal to the left because we're making the number smaller. Okay? So let's look at this first problem here. We have 2.83 times 10 to the first power. So I'm going to move my decimal one place, and because it's a positive, I'm going to move it one place to the right. So in order to write this in standard form, or decimal form, 28.3 is our new answer. Okay, see how 28.3 is larger than 2.83? The next one that I have is 4.9 times 10 to the positive fifth power. So I'm going to move to the right to make it bigger, okay? Now my decimal is here, and I look and I can move it one spot, but I don't have any other numbers. So what we're going to do is we're going to keep going. So 1, 2, 3, 4, 5. In every little space that I have, an opening, I don't have a number, I'm going to place zeros there. So we are going to have 4, 9, then 0, 0, 0, 0. So we have 490,000 is our answer in decimal form. Now, let me quickly tell you a mistake that people make when they're doing scientific notation is they say, oh, this just means how many zeros you put. No, that is not correct at all. It's how many places you move the decimal. Okay, now we look at the third problem, and I have a negative number. And I look at the first number that they gave me, and I don't see a decimal at all. Anytime you have a number that does not already have a decimal, it is automatically at the end, okay? So, if it's -2, I want to move it 2 places, and this time to the left, because I'm trying to make it smaller. So 1, 2, and my decimal is going to be here, so I'm going to have 0.08. And if you want to put a 0 in front of the decimal, that's fine, but you don't have to. So see how 0.08 is smaller than 8, the number we started out with. Now I look at the next problem, 1.23 times 10 to the negative third power. So I'm going to move 3 times, and I'm going to go to the left, 1, 2, 3. So my decimal, I have 0.00123. Here's my answer in decimal form. So that's how we do scientific notation to decimal. So now what we're going to do is we're going to do the opposite. I've got a number, and they want me to write it in scientific notation. And it is the exact opposite of what we just did. Okay, so this is why scientific notation is tricky for people, is because you think, oh, to the left is negative, to the right is positive. Not necessarily, okay? It is when you're doing what we just did, but now that we're going to do decimal to scientific, it's the exact opposite. So I look, one thing that you have to know about scientific notation is there is always one digit in front of the decimal. You might want to write this down. I know I would. Now, when I say digit, a digit is any number 1 through 9. Okay, that's a digit. 0 does not count, and 10 does not count, okay, and any number other than that. So a digit is the numbers 1 through 9, and there's always going to be one digit in front of the decimal. That is scientific notation, okay? So if I don't have it written like that, if I have like 23.8, that's not scientific notation because how many digits are in front of the decimal? 2, 2, and 3, 23, okay? So I look at this problem right here, 34,000. And I need to say, first of all, where is the decimal? Well, if I don't see it, I know it's right here at the end. And where does it need to go so that there is one digit in front of the decimal? Right here between the 3 and 4, because this is going to be the digit in front of the decimal. So I say, okay, I need to go from the blue dot to the red dot. That means I need to move 1, 2, 3, 4 places. So I'm going to write 3.4. And when you have zeros, you can leave those zeros off. You only have to write digits in scientific notation. So 3.4 times 10 to the positive fourth power. And you say, wait a second, we moved to the left. I thought when you moved to the left it was a negative. It is the exact opposite in decimal to scientific notation. When we move to the left, it's a positive exponent. You say, okay, hold on, I'm totally confused. Well, let's ask ourselves this. Let's take the answer that we just got, and let's try to take it back and write it in regular form. 3.4 times 10 to the fourth power. I'm going to move it 4 places to the right because I'm trying to make my number bigger, and it would equal 34,000. See how that works? So this is my answer. You can always find out if your scientific notation is correct by expanding it again, and if it matches your original problem, you know you did it right. Now look at this next problem. It's kind of a trick question. In scientific notation, how many digits are in front of the decimal? 1. Well, I look and here's my decimal. I have a digit in front of it. So 1.78 is technically in scientific notation without the times 10 to the whatever power. So what I'm going to do is I'm going to say, okay, times 10, how many places did I have to move the decimal? None. So it's going to be times 10 to the 0 power. And then last but not least, we have our problem here, 0.0007. So I need one digit in front of the decimal. You say, oh, well, perfect. We've already got one digit. No, is 0 a digit? No, it's not. So I have to take my decimal from where it is, which is right here, and I need to make it so that it moves so that there's one digit in front of the decimal, which is this 7 right here. I want it to become in front. So I say, okay, I need to move it 1, 2, 3, 4 places. So I'm going to have 7.0, or you could just write 7 times 10 to the fourth power. And is it going to be a positive 4 or a negative 4? It's going to be a negative 4 because I moved to the right, which is a negative exponent in these problems. Okay, you say, well, hold on a second. Let's ask ourselves, how could I make this back to the original? I would have to go 1, 2, 3, 4 places to the left, and then that would match my original problem. Okay, so this is how we take a decimal number and make it into, scientific notation.